Okay, I think we're good to start. So, hi everyone. Thank you so much for joining the presentation. I hope that you enjoy what I have to say to you today. And what we're going to talk a little bit is Quarkus and Knative, and a little bit about microprofile. So, don't really mind the subject of the presentation because I'm going to talk about a lot of crazy things. But anyway, just really quick about myself. So I'm Roberto. I work for Red Hat, and I mostly work around Quarkus and microprofile technologies, and everything that has to deal with microservices. So that's usually the things that I work on. So if you're interested in this area, so feel free to reach out at any time, and I'll be happy to discuss any kind of subject with you around this area. Okay, so let's start with the first thing, right? So I'm not sure if you heard about Quarkus before or not, but let's try to introduce it really quick. So if you heard about Quarkus and you're using it, that's great. If you haven't, then here's a chance to learn a little bit about it. I think it's a very exciting technology. So, and I mean, maybe a little bit biased because I work on that, but at least I believe so. But anyway, Quarkus is something that is a completely open source project, and we like to call it as a stack that you're able to write any kind of Java apps, mostly targeting cloud environments like any cloud infrastructure, of course, but you can use it to write microservices. You can use it to write serverless. So we are mostly targeting these areas, but the interesting thing is that we've seen other people using it for a lot of other stuff. Like, for instance, developing CLI applications or even monoliths. I mean, even though we're targeting these environments, doesn't really matter. You can build any kind of application with Quarkus. Now, of course, probably the last thing that you'll be asking about is why I should be using Quarkus, right? Now, let me try to introduce another topic here today, which is a little bit what you call the hidden truth about Java and containers, right? Now, I'm not going to go very deep into this topic, right? Because there are like a lot of lectures around it, and there's a lot of books. So if you want to learn more, so feel free to search about this area. But when we started all this effort of like moving stuff from bare metal to the cloud, right? We start seeing these overheads, right, of what we have in memory, especially because we have to scale our applications to numbers that we haven't seen before, right? So if you pick, for instance, one application that needs to scale to 200, 100, 1,000 nodes, right? There's always going to be a delay, of course, of the startup time. But if you think about it, there's also a memory usage that you have when you're starting the application, which corresponds to classes that you're loading on the JVM, and that never changes, right? If you're running the same version of the application, all of them. Now, this of course has some hidden costs, right? Especially because you haven't, maybe you've seen this, maybe you haven't seen this before. Now, when you're running things on bare metal, usually you didn't pay much attention to this because running on bare metal, you most likely will buy a server or a few hundred of servers, and all capacity was already there. So if you have to increase the capacity, you'll just increase it by changing some of the numbers. But that cost was already paid. It was done upfront. Now on cloud providers, things are a little bit of the opposite. Now, instead of you paying for a fixed set of resources, you pay exactly for what you consume. So if your application is consuming more memory, you're gonna see that straight away by the budget that you have to pay for your cloud provider services. The same thing if you're using more CPU, you're gonna pay more. Now, there's like a big shift on how you're gonna manage your resources, right? So one is managing resources that you already have. The other one is managing the application resources, in the sense that as much resources the application consumes, the more you're going to pay, because that's how cloud providers operate. And of course, this becomes important now to try to understand a little more on how JVM works in that regard, right? Now, there is this overhead of some things that Java loads, right? And if you compare it with other technologies, because Java always has this way of working, and of course, this slide here is not on scale. It's just for you to have an idea. But usually, you're able to fit more Node.js or Go applications in the same amount of resources as a Java application. And this is because, yes, Java is somehow memory hungry, even though, of course, you can say that it has some other advantages across the other technologies. But we're not going to come into any kind of technology war right now. We're just looking into the memory consumption at the moment. So one of our challenges was we wanted to make Java more competitive, or at least writing Java applications more competitive to other technologies like Node.js and Go. Now, and again, this slide is not at scale, but if you pick up a traditional cloud Java stack, of course, you have some time of memory usage. And what we wanted to do with Quarkus was to be able to fit in more Quarkus instances using developing an application in plain Java in the same amount of resources compared to other Java technologies. And then, of course, come into a way where we can compare ourselves with Node or Go. And we believe we have done that. Now, how we have done that, of course, you might be asking. Well, of course, we try to give you a lot of other benefits, not only the Java memory, and I'm going to go a little bit more in detail just in a sec. Now, we know that trying to convince people just on performance arguments is not a good thing, even though, of course, it's something important. So we try to give a lot of other aspects that make the development environment as much pleasant as possible for people that are trying to start or migrating an application to Quarkus. So what can we find? So one is it's what we call developer joy. So one of the things I try to do is have zero configuration, and we have or what we call our live reload that I wanted to demo after I'm done with the presentation. The live reload is one of the biggest features that we have, so it allows you to write your code, and you can basically hit the refresh button. If you're, for instance, building a web application, you can hit the refresh button of your browser, and you see instantly all the changes that you have written on your code, so you don't have to stop the application, restart, and redeploy the application again. We try to give it as much standards as possible. So a lot of what we show in Quarkus is using the libraries that have been with Java for a long time. So we used to joke about this, that maybe if you haven't started using any Quarkus applications, you already have like 5 or 6 years of experience, because the code is very much alike with things that you probably have done in the past. Now, memory-wise, so this is just a tryout that we did with a simple REST application, and we've seen that a traditional cloud native stack may occupy like 130 megs of memory. Now in Quarkus, we usually see like half of that size, and if we even take that further, which using Quarkus compiled with native image of GraalVM, we're talking like a tenth of the size, so like just 10 megabytes, which is completely crazy, right? If we compare it with an application that's a little more elaborated, with a CRUD and a database, right? So a REST application with let's just say maybe like a bookstore, we've seen that the cloud native stack cloud native stack for traditional for Java might take like 200 megs, and Quarkus is a little bit higher than or compared to the last example, but still lower than 200 megs. So we're talking about 145. But still, if you go with native, we see like, again, a tenth of the size of what we're doing, right? So I think these are really interesting numbers. Now, we've also seen that at startup times, right? So a traditional cloud native stack may take like 5 or 10 seconds to start. We usually see like sometimes like sub-second starts on Quarkus, depending, of course, on the application size. But usually it's like a tenth of the time that you take to start a normal application. And if you're talking native, then we're talking like a few milliseconds only to start, which is really, really great. Another thing is that, of course, like a lot of people are interested in reactive world, so we try to also come up with a good way for you to implement reactive applications, and you're able to even mix both just by changing a couple of annotations or annotating your code. So writing a REST endpoint that's either imperative or reactive is mostly the same. Just change a couple of annotations and you're done. And as I mentioned before, I mean, we do integrate with a lot of other libraries, so you can expect things like Kafka, MicroProfile, Hibernate, Camel, Kubernetes, Spring, right? So you'll be mostly comfortable with all these APIs, and you can use any of them to write a Quarkus application. Now, yes, I mentioned a lot of events over here, but I think it's interesting to tell you a little bit of how Quarkus works at the architectural level, so you can actually figure out how we're able to have all of these advantages, right? So it's not something that I'm just saying over here just because, right? Now, traditional, if you pick up for instance, Spring or a Wildfly application or a WebSphere application, doesn't really matter. What you usually have is you build your application, you create a WAR file or a jar file, doesn't really matter, and then you pass that compiled jar or WAR to whatever runtime has to start at. And what the runtime is going to do is going to pick up that jar. It's going to open that up. It's going to try to read the configuration. It's going to do class path scanning. Sometimes, depending on the libraries, it may require multiple scans on the class path. It may build like a module of your application in memory, and then it starts up thread pool, starts up a lot of other stuff, and then only after all of those operations are done, then that's when the application is actually ready to start. Now, if you now make a parallel on this, on what I was telling you about cloud providers, if you have 100 nodes running on your cloud provider and you take like 10 seconds to start, and those 10 seconds you're only doing these operations that are always the same on every node. So opening the jar, doing the class path scan, finding the configuration, finding a lot of other stuff, right? Initialization blocks, starting the code. So mostly it's going to be the same. So those are 10 seconds or 20 or whatever time it takes that you're going to be paying your cloud provider while you're not doing any actual useful work for yourself. Yeah, right? So we will consider that the actual useful work for yourself is when you serve the first request. That's when you're actually serving your customers or your clients. Now, one of the things that we did on Quarkus, we shifted things around. And one of the things that we did was try to pass as much as possible things that will happen in runtime to compile, right? So let's just say instead of you having to do class path scanning and loading configurations during runtime, we do that on compile time, right? And so the end result is it's going to require less startup time to start your application. And also it's going to occupy less memory because let's just say you have a piece of code that has to read some kind of configuration or do some class path scanning. Because you've already done that on compile time, you don't need that anymore, and then you can throw it away. So of course that means that it's going to be less memory at the JVM. I think that this is a very easy concept to grasp, at least architecturally, and implementation-wise, that's a different story. But this is the basic concept on Quarkus. We try to move as much as possible all the work that happens on runtime to compile time. Not everything can be done in compile time, but we can do a lot of stuff over there. Now, one of the main motivations to try to do as much as possible at compile time was because of GraalVM. And I'm going to talk a little bit about the GraalVM before, but basically this is what makes possible then for us to compile things in native, which take those sub-millisecond startup times and occupy even less memory. Now, a couple other things that I haven't mentioned, which are also very interesting, right? That not only explains what we do on compile time, but also help you understand how we're able to use even less memory and even make it the application even faster is, if you probably know, a lot of frameworks use reflection to pick up stuff, right? Or to call other services. Now, I mean, I love reflection. Reflection is a great thing in Java, but of course, it's never going to have the peak performance of a regular method call. Now, one of the things that we try to do is we try to remove as much of reflection as possible, and we just generate bytecode directly on compile time that will serve whatever dynamic proxy you have or whatever reflection call you might have. So in the sense, when you're running the application, you don't have any reflection anymore, but you just have a direct method call, which of course is going to be much faster than using reflection. Now, what are the actual benefits of, I mean, I explained all of that, but let's just do like a quick summary, right? So we do the work once, not at each start, right? So if you think about it, when you're deploying an application or application version to your cloud provider, you'd only compile the binary once, and then you distribute them across all your nodes. If most of the work is already done, then those nodes don't have to repeat that work at each start, right? So the bootstrap classes are no longer loaded, right? As I mentioned, if you already done all the class path scanning, you don't require that code anymore, so you can just remove it and throw it away. And of course, that leads to less time to start and less memory usage. And in the end, it's going to be less cost for you on your cloud provider. No reflection, or, well, we do have some reflection. There is no way for us to get rid of all reflection, but at least as less reflection and less dynamic proxies around. So the code is going to be faster to execute as well. Now, and how we can accomplish all of this? So we have something that we call Quarkus Extensions, right? And they contain the logic to make a library compatible what we described before. Now, a lot of the things that I've mentioned in the past about integration with Camel, Hibernate, even Spring, those extensions were written by the Quarkus team. And what we actually do on an extension is we look into the library code, and then we try to extract as much as possible to do things in build time, right? Now, because Quarkus is still Java, you can use whatever library is available to you. So there is no restriction over there. The extension itself is just for you to be able to take advantage of this build time module. So if you want to use a library that doesn't have a Quarkus extension, you're free to do so. But most likely, you're not gonna, of course, be able to take these advantages of trying to occupy less memory and have less startup time on that particular library, of course. If you like, of course, I mean, it's not really that hard. You can build your own. They're like the extension model has a really clean API, and it might be a little bit tricky to get into startup, but once you get the hang of it, then it's quite easy to understand, and you're good to go. Now, a lot of people may think that Quarkus is just a native compiler, or it's just something that allows you to build REST applications, or just for the cloud. Well, in my opinion, Quarkus is so much more than that. But let's say that what Quarkus is not. So it's definitely just not a native compiler. So while you can use it as a native compiler with GraalVM, you can run Quarkus as a completely regular JVM as a Java application. It's not only just for REST. It's not only just for small applications. You can build monoliths. We've seen Quarkus being used, for instance, for embedded devices on Raspberry Pis, because since the footprint is so small, it's quite perfect for those environments. But still, we've seen also people using it to write their own monoliths like they've done in the past, because it still had advantages memory-wise and startup time-wise. It's not a copy of Spring. I mean, we even integrate with some of the Spring APIs, but we don't try to copy what Spring does. We try to build our own stuff. And it's not just another framework. We like to call it as a platform where we're able to serve multiple use cases. And if you come up with something new, then we are more than happy to try to integrate that and figure something out. Now, native image. So let's talk a little bit about that. So I'm not sure if you heard about GraalVM. So really quick. So GraalVM is a project coming from Oracle Labs, and not only is they provide a JVM implementation, but also come with a very interesting approach and a very interesting tool called the native image. So native image allows you to actually have a closed world assumption of your application, build it, and then run it as a completely standalone binary without the JVM. There's still going to be a lot of other things involved, right? So instead of running on the JVM like Hotspot or J9 or whatever, there is another VM called Substrat VM, but that's nothing that you cannot compare it to the JVM, something completely different, right? And so basically what it does is this tool does is basically it looks into the code and tries to build a binary image of your application, so then you can run it on, I'm not going to say any environment, because it's going to be tied to the architecture where you actually run it or actually compile it, and then you can run it without any further hassle. But if we have like some old developers over here, well, then maybe they don't need to be old, but if you build like some C applications, this is quite similar on what happens when you build like a C application, right? When you have to build your code into a binary distributable, and you have to build it for multiple architectures, right? So here is something, the process is somehow similar, and of course, it's going to take time. So like when you, for instance, if you're building a traditional Java application, sometimes it just take like a few seconds. In here, depending on the application size, of course, it may take several minutes. So it's not something that you should be doing all the time. But let's see some of the cases where you can actually do it. Now, this seems to be very interesting, right? But of course, everything that if you're thinking, well, I mean, native image seems to be awesome. There is no JDK involved. It has like sub-millisecond startup times, right? But of course, there are some things that we call the dark side, right? A lot of things that are not supported. So one of the things is dynamic class loading. So Java and mostly Java frameworks and libraries abuse this a lot. And so that's one of the things that we try to do on our extensions is do everything that requires to be on a class path at build time. Other things like invoke dynamic and method handles from the JVM are also not supported, right? And then like security managers, finalizers, right? Those are not supported either, even though most people don't use them anymore. And then there are things that are supported, but they have some few limitations, right? So for instance, reflection is supported, but you need to tell the native image which reflection calls are going to be uses on your application. And this is because, well, if you don't give him a list, then the native image doesn't know if you're going to call a method by reflection or not, right? Only when it's going to actually call the code. So that's not very interesting, because if it doesn't know the list, then it will have to include all the JVM and all the library code out there, because it doesn't know what's going to be called. Now that's why when reflection support was added, okay, well, native image is supported with reflection, but it needs to be indicated which reflection methods are going to be called. So we only include those, and we keep the binary size and the memory size low, so we don't have to include everything. right? And the same thing applies to dynamic proxies, right? So the similar concept and so on. So there are some limitations so using the native image. Now, when will you like to use one or the other? So right now, I mean, they have different peak performances, right? So for instance, the JDK is still going to be high memory density requirements, right? So it's going to have the best raw performance for CPU, best garbage collectors. So it's still better for high throughput. Now, the native image is more interesting when you want to have things like serverless, or you want to just have really startup times where you just only want to handle a few requests. Well, I mean, it does. You're able to serve thousands of requests with native image anyway. It's just not going to have the same throughput as a VM. So if you have like low heap sizes, it's also great. We've seen people that actually combine both of them, so you can have like a few nodes running on VMs, and you have a few other nodes running on native image. So you'll get the feeling when you try it, right? Okay, so I've been talking for a while, but I wanted to actually show a little bit of Quarkus, and so I'm gonna try to do a demo for you. So let's see. Let me go to my IDE. So this is not what I want to show you first. Okay, trying to search here my mouse. There we go. So here, so this project I'm going to show is on GitHub, so you can pick that up, right? So this is a microprofile application, and let me actually start by showing you the POM. So Quarkus works with Maven, with Gradle, so whatever build tool you want to use, feel free to use that. Now, if I show the POM, it's nothing really out of the ordinary. So I have a few dependencies, right? Really simple. Now, the thing that you might be noticing is you'll see that instead of using regular JUnit, we use the Quarkus JUnit. Or if you want to use Kubernetes, we use Quarkus Kubernetes. So basically, here are the dependency extension that we're using, right? That wraps the original library code. So you can take advantages of the build time architecture that we have. But for instance, rest assured, we don't really require that, so you just use the regular dependency. Now, again, if you want to use like a regular Kubernetes or let's just say here OpenTelemetry that I'm using, you can use the regular dependency, just not going to have the advantages that I mentioned in Quarkus. Anyway, this is not really a problem because we just ship with a BOM file, and then you can just include whatever dependencies you want. Now, if I show a little bit of the code, most likely you're going to recognize these codes. So in here, this is just a simple REST endpoint with some annotation. So this is using JAX-RS. So if you build JAX-RS applications, you're very familiar with this code. So this is just an interface. The implementation is right here. And then here's using CDI to inject some stuff. Not really groundbreaking. But if I come here to my Java production sources and I search for Quarkus, you're not even able to find anything. So I'm not even using any Quarkus import over here. So everything is just standard Java code. It's just JAX-RS or CDI. I even have another application over here. And if I search for Quarkus, I might be able to find one or two. So I actually have one here, which is like a JSON video serializer, just to save some time. But everything else, if I have like a persistence, which is using like regular JPA with Hibernate. So all the knowledge that most likely you have building Java applications, you'll be able to reuse when building a Quarkus app. Okay, so here is like a very small application. The book one is a little bit bigger. So the number resource just generates like a random number. The idea is that you're able to generate it to create the SPNs for the bookstore. So I'm coming in here to my terminal. Let me just increase this a little bit. And you can run this Java application or this Quarkus application by running Quarkus dev. And this is going to run Quarkus as a development mode. And because it's development, oops, sorry. Let me just go to the browser. Yeah, let me take this out of full screen. And yes, so now it's running Quarkus as development mode. So it takes a little bit more time to start in development mode, and even more because I'm running a lot of stuff in my box. But I can come over here. So this is running on localhost 8080. And if I come over here, you'll see like a small thing. So there's nothing over there, but it gives you some endpoints that are available. So this is like Swagger UI, which is also included over there. And then I can just try to invoke my REST endpoint, and I get like a number over there. So if I keep invoking that, that works fine. Well, I can just invoke the REST one directly into my browser as well. And that should work fine. I'll just increase that. And one of the things that I'm going to come and do right now is I'm going to come over here. I'm just going to say, hello, JDD, Krakow. And if I hit refresh, oops, so let me see what actually happened over here. Oh, I got it. Sorry, never mind. I'm actually running these on Kubernetes, not over there. So my Kubernetes cluster is actually actually has that application running. So so minus delete f target. Okay. Yeah, sorry. The one that I was showing was the Kubernetes one, not the one running on dev, which should work. I should be able to put that reloadable as well. I'll show that later. But hopefully this should work right now. Okay, so here's the refresh. So this is okay. And okay, so now you might be saying, okay, this didn't count because you already compiled the code. So let me remove a couple of things over here. So I hit refresh, and you see like whatever I changes here on my Java code, it was recently reloaded directly here on my browser, right? And I mean, I done a very simple change, but I can come over here and I can create like a completely new REST, sorry, and a completely new REST endpoint, right? So with a get, right, and path, not patch, path, hello, and now we need to go to the implementation, and let's say implement the method, right? And well, let's just copy here. And because I mean JDD, we say Poland, we say Krakow, but I know that probably more people are seen in Poland, so load JDD Poland like that. And now if I come over here in my Swagger UI, now you'll see there is like this number as hello endpoint, right? And if I invoke it, you'll get whatever I just written over there. Of course, if I come and invoke the endpoint directly, you get that one over here. So as you can see, I'm pretty much changing my code. And if I hit refresh, I'll just get instant changes. Now, it didn't work before because I was actually, oh, sorry, let me do this in a little bit easier. Let's just copy this portion. So it didn't work before because I had an instance running on Kubernetes, and that one was shadowing my own. Now, what I'm doing is I'm just generating a Docker build of that application, and I'm deploying that directly into Kubernetes that I'm running locally. And you can see it was super fast. And now I can say kubectl get pods. See, not like that. kubectl get pods. And I have a number over there. So now it's number API running. And I can say kubectl logs number API. So you see now Quarkus is running over there. There is like some errors over there that's about OpenTelemetry that's not running. So let's forget about that. And I can even say now Quarkus remote. I think it's like this. I can say Quarkus remote dev. And the interesting thing about remote dev is now it's actually going to connect with my Quarkus that's running on Kubernetes. And I have the exact same experience that I had before by reloading stuff in an application that's running on Kubernetes, right? So if I come over here, so everything is pretty much as I had it before, right? So hello, JDD Poland. Then I'm going to come here. Let's just remove a couple of things. So just say hello, JDD now. And let's hit refresh. So it takes a little bit longer because I mean it's on Kubernetes, right? But now you have the exact same experience you have on Kubernetes, which is quite interesting because sometimes you might be having some services on some enterprise Kubernetes that you don't have locally, and you might want to try out your application over there. So these give you a way on how to do it. Okay, so let me show you one other thing. So I'm not really let's go. I don't really remember some of these codes, so I have to unshelve it over here. But let me just re-import it into the browser. So most likely you recognize these code over here. So this is Spring code. So it's a REST controller, right, and a request mapping. It should. Let me see. Okay, so the browser already reload that. So I'm going to run Quarkus dev again. But the point that I want to show you over here now is that you can, if you don't feel comfortable using JAX-RS and maybe more experienced or comfortable with Spring, you can use the Spring API to build your own REST endpoints like this, right? So if I come here to my application and go to Swagger UI, so let's see if I already reloaded. Yes, I'll have. Oh, it's not. I don't think. Oh, sorry. Now. Kubernetes is still running, so I have to remove that. Yeah, sorry about that. So let's run dev mode again. Okay, so if I reload this, you'll see there is a greeting over here. It's a Spring resource, right? You can invoke it like the one that I was doing it before. And the coolest thing is, oh, this is JSON, doesn't really work. I need to change the media type. Well, I'll just invoke it here directly. We have a hello, and the coolest thing is a Spring resource with hot reload into Quarkus. So you can change the Spring code to be like this. Okay, I don't think I have much time left. So the last thing I'm going to do is I'm going to, let's do it like this. I'm going to do a native build. This is going to take some time. So if you have any questions, I can take some right now. But basically, this is the one that's building with the native image. As you can see, it's doing a lot of other stuff now. It depends on the size of the application. It can take like 2 or 3 minutes to build. Probably maybe sometime more because of everything that's running on my box. So hopefully it's not going to take too much time. But this is just the binary mode of that application. So the application is just being scanned by all the stuff. Everything's being resolved. Everything's being removed that doesn't need to be there. So in the end, you're just going to have a single binary file that you can run even from a Docker container. And this is going to be an application that has like really low memory footprint. So while that one is building, let me just do something really quick here. So if I come to that project again, services, number API, and I run on Quarkus Dev, and let me open here monitor really quick. So I have a lot of stuff running. So if I list all the Java processes that I have one with 200 megs, a few with a few jigs. So one of them is actually GraalVM compiling. The other ones are probably the IDE. But you can see that all Java processes are all above 200 meg, right? So and one of them is going to be Quarkus as well. So this one is already done. It took a little less than 2 minutes. So I'm going to do something that you should never do, right? So if you go on target, you'll see there is a number API runner over here with 62 megs of size. And if I do a cat target number API runner, you'll see that this is a completely binary file. And now I'm just how they run binary files. It's a number API runner with a /. And now you see that this application just was completely instant. It started in, let me see, sorry. Okay, it's over here, 24 milliseconds, right? And if I go to my monitor and now I search for something like called number API, you'll see there's only, let me just increase this a little bit. You'll see there's only 12 meg on that application. Okay, so this is just for you to have a little taste on how native image works and the advantages you can get out of that. So I think they're pretty much done with the presentation for now. So I'm going to say back to the studio and see if we still have some time for QA.